There are discoveries that shake astronomy. Discoveries that puzzle scientists for years. And then there are discoveries that reach even deeper, discoveries that do not simply add new information, but challenge the foundations of what we thought we understood about the universe. For decades, modern cosmology seemed remarkably stable. According to the standard picture, the universe began around 13.8 billion years ago in an extremely hot and dense state. Space expanded, matter cooled, the first stars formed, and small galaxies gradually merged into larger ones. The story appeared orderly and predictable. Astronomers imagined the early universe as a place of cosmic infancy, dim, primitive, and still taking its first steps toward complexity. Then the James Webb Space Telescope began looking farther back in time than any observatory before it. Because light takes time to travel, looking deeper into space means looking further into the past. Webb was designed to observe the first generations of stars and galaxies emerging from cosmic darkness. Scientists expected to find small, faint, immature structures still in the process of formation. Instead, Webb found something unexpected. It found galaxies that appeared surprisingly bright, massive, and evolved at extraordinarily early periods in cosmic history. These objects were not impossible according to physics, but they seemed to have developed much faster than existing models predicted. Some appeared when the universe was only a few 100 million years old, an instant compared to its current age. To many astronomers, it felt like opening a history book to the first chapter and discovering entire civilizations already flourishing. The universe appeared to be moving faster than expected. Using spectroscopy, researchers measured enormous redshifts that confirmed these galaxies were indeed extremely distant. The farther scientists looked, the more examples appeared. Instead of isolated anomalies, Webb seemed to reveal entire populations of unexpectedly massive galaxies in the young universe. That created a challenge. According to standard models, galaxies should grow gradually. Gas clouds collapse, stars form, gravity pulls matter together, and structures slowly evolve over time. Yet some of Webb's observations suggested that complexity emerged much earlier than anticipated. This does not mean the Big Bang is wrong. It does not mean cosmology has failed. But it does create tension between observation and prediction, and throughout the history of science, that tension has often led to major breakthroughs. Scientists are now asking difficult questions. Were conditions in the early universe different than expected? Could star formation have occurred far more efficiently? Did giant black holes grow rapidly and influence surrounding regions? Could dark matter have behaved differently under extreme conditions? At the moment, no one knows for certain. Another surprise involves the speed of star formation itself. Some early galaxies appear astonishingly productive, creating stars at rates far beyond what many researchers anticipated. Matter seems to have gathered quickly, and entire systems appear to have matured in a remarkably short time. The challenge is not whether these galaxies can exist. The challenge is explaining how they formed so quickly. Perhaps the early universe contained conditions that accelerated growth. Perhaps there are mechanisms that current models do not yet fully capture. Whatever the explanation turns out to be, Webb is revealing that the universe may have been far more dynamic in its youth than previously imagined. And that realization carries an emotional impact beyond science. Most people imagine the early cosmos as a quiet and empty place slowly awakening. Webb instead hints at a universe already active, already building structures, already racing forward. It feels less like witnessing the beginning of a story and more like arriving after the story has already begun. That is why these discoveries have attracted so much attention. They remind us that scientific understanding is never final. Every generation reaches a point where observations challenge accepted ideas and force researchers to look deeper. History has seen this before. Humanity once believed Earth stood at the center of the universe. It did not. We once believed our galaxy contained everything that existed. It did not. Each time certainty seemed complete, reality revealed a larger mystery waiting beyond the horizon. The James Webb Space Telescope may be bringing us to another such moment. Not because it has overturned modern cosmology, but because it has exposed questions that cannot easily be ignored. Perhaps Webb's most important discovery is not a specific galaxy or record-breaking redshift. Perhaps its greatest discovery is a reminder. A reminder that the universe remains far stranger than we imagine, and that even our best explanations may be only part of a much larger story. Webb looked toward the dawn of cosmic history, expecting to witness the universe taking its first hesitant steps. Instead, it may have found a universe that was already running. And if future observations confirm that picture, the discoveries ahead may do far more than rewrite astronomy. They may transform our understanding of how the cosmos